Let us look at this interesting American mathematics competition problem, problem 20. It's actually a little bit tricky for a problem 20. Let's look at this. In triangle ABC, points D and E lie on BC and AC respectively. If AD and BE intersect at T, so that AT over DT equals 3 and BT over ET equals 4, what is the ratio CD over BD? One of the things we notice is that all the information is expressed as ratios, so the answer to the problem is not going to depend on the size of the triangle. Well, as a starting point, let's write the formula for the area of a triangle. So area of a triangle is just 1/2 times the base times the height. If two triangles have the same bases, and we see a lot of these triangles here in this diagram, like we could consider triangle ADB and ADC, if they have the same height, then their bases are proportional to their areas. So let's write this down. We would have the area of triangle 1 divided by the area of triangle 2. It's just the base of triangle 1 divided by the base of triangle 2. And that's if the two heights are the same. So that's if h1 is equal to h2, and that just follows from the formula for the area. So let's apply this proportion relationship here to a bunch of different configurations here. Let's first look at triangle ACD and triangle ABD. So what we can say is that CD over BD is equal to the area of triangle ACD, which is here, ACD, divided by the area of triangle ABD. So now let's look at triangle ABD. If it's composed of two triangles, ABT and BTD, so let's try to find the areas of each of these triangles. Now, because the answer is not going to depend on the size of the triangle, we can assume that the area of triangle BDT is equal to 1. And because the ratio AT over DT is equal to 3, we know that the area of triangle ABT is going to be 3 times the area of triangle DBT. That's because of this formula here. So we know that this here is going to be equal to 3, the area. And now let's just look at triangles ABT and ATE. Well, we know that it's given here the ratio BT over ET equals to 4. So we know that the area of the triangle AT is going to be 1/4 of the area of triangle ABT. So this is going to be 3/4. And now let's compute the area of this shape here, TDCE, which is a quadrilateral. Now we don't know any easy formulas for the area of a quadrilateral, so we have to do something a little clever here. And the most natural thing to do is to try to break it into two subtriangles. And now we have a couple choices here. We can either use segment DE or segment TC. Now if we try to use segment DE, and this is not going to lead anywhere, so it seems most natural anyway to use segment TC, because point T is kind of the center of our picture here and is a central point. So let's break it like this, and let's find the areas of those two triangles TDC. Let's let that be X, and area of triangle TEC, let's let be Y. And let's see what kind of relationship we can obtain to solve for X and Y. So now let's bring in two triangles here. Let's look at triangles BTC. Let me highlight that triangle. BTC. And let's look at triangle TEC. So now we have two triangles that have the same height with a common vertex at C, and we know the ratio BT over ET equals to 4. So we can write down that 1 plus X, which is the area of triangle BTC, divided by Y, which is the area of triangle TEC, that must be equal to 4. And similarly, if we look at triangles ATC and triangle DTC, well, because AT over DT equals 3, similarly we can write the fact that 3/4 plus Y, and that's the area of triangle ATC, divided by X, which is the area of triangle TDC, this must be equal to 3. So now we have our two equations. Let's do some simplification. Let's multiply both sides of this equation by Y, so we get 1 plus X equals 4Y. And here let's multiply both sides by X. This equation here, multiply by X, so gets 3/4 plus Y equals 3X. And we can also multiply by 4 now to actually get rid of the fraction, to get 4Y. So we'll get 3 plus 4Y equals 12X. Alright, so let's solve this system of equations. It's a linear system, 2 by 2. So now we know that 4y equals 1 plus x. So let's substitute 4y into this equation right here. And we obtain 3 plus 4y, which is 1 plus x, from here, equals 12x. So that's the same as 4 equals 11x, or x equals 4 over 11. From this we can obtain y, say, using this equation here. So we get 4y equals 1 plus x, which is 1 plus 4 elevenths, which is same as 11 over 11 plus 4 over 11, which is 15 over 11. So we obtain y equals, by dividing by 4, 15 over 44. So the upshot of this is that x plus y, which is the area of quadrilateral TDCE, x plus y is equal to 4 divided by 11, x is here, plus y, 15 over 44, and using a common denominator we get, multiply this first fraction by 4, 16 over 44 plus 15 over 44, which is equal to 31 over 44. Therefore, if we go back to this equation here, CD over BC, we obtain CD over BC is equal to, let's a little back up here. Well, area of triangle ACD, which is here, ACD. Now the area of this is 3/4. This one here is 3/4 plus the area of this quadrilateral, x plus y, which is 31 over 44 right here, divided by area of triangle ABD, which is just 3 plus 1, area of triangle ABD. So that's 4. So let's write this as, let's use a common denominator here, 44, meaning multiply this by 11, top and bottom. So we get 33 over 44 plus 31 over 44 divided by 4, so same as times 1/4. And this is 64 over 44 times 1/4. And this is just equal to, let's simplify here, 64 and 4 give us 16. So it's just 16 over 44, which is just equal to 4 over 11. So the answer was 4 over 11. D.